everyone, and welcome to the CMU CS Academy CSEdWeek YouTube live session. This is our last one of the week, and it is a word from our developers. Stephanie, I'll let you kind of take it from here and run with it.
Yeah, hi everyone. So welcome to the CMU CS Academy word from our developer session. We're just going to be going through a little bit of introductions, then we're going to go through a little bit of talking about some of the tools that CMU CS Academy developers use, and then we're going to go through a little bit of a code demo with some of the tools that we were talking about, and we'll finally move on to doing a Q&A with prepared and any questions from the audience. But yeah, I'll just first begin with my introduction. My name's Stephanie. I'm currently a second year studying CS here at CMU, and on what I've worked on is CMU CS Academy as a developer. I've worked on the testing team, so making sure that components of the website are working as they should. So I'll pass it off to Sean.
Perfect. Thank you, Stephanie. My name is Sean. I'm a sophomore majoring in information system in CMU, currently on the outreach team on CS Academy, doing the summer work at the web dev team, and I will pass it off to Tate.
Yeah, hello everybody. I'm Tate. I'm a senior at CMU studying biological sciences and minoring in computer science. And kind of similar to Sean, I work on the teacher outreach team during the school year, and during the summers I work on the dev team. And I'll pass it off to Austin.
Hey everybody, I'm Austin. I used to be on the student team working as an undergrad on the project, but now I work as a full-time software developer. Graduated to the big leagues. And
great.
Who are you, Evan?
The last one. I'm Evan. I'm a full-time employee. I've worked on CS Academy for about 3.5 years. So I'm the head programmer on the team. And yeah, thanks for being with us.
Yeah, so I'm just gonna pass it off to Sean. And he's gonna tell us a little bit about understanding HTML, CSS, and JavaScript, and how those components play into using in the CMU CS Academy website.
Thanks. And I guess to start off, when I was in high school, when I look at web developers, I always thought like they're wizards. And coming into CMU, I realized like we're better than wizard. We don't use our magic to fight other wizards. We actually use it to build something that's useful. And in order to understand our wizardry, in which Austin will showcase later, I think it will be pretty crucial for us to understand the 3 main components in which I will quickly talk about, just to give you a general overview. So in what we do, the 3 components that we usually work with are HTML, CSS, and JavaScript, as you can see on the left. And in short, HTML, CSS, and JavaScript are content layout and the interaction that you see on the website. So going through them one by one, HTML basically is the structure or the content of the website. Stephanie, if you look at if you click on the website over here, you can see the basic animations, giving programs the basic animations and all the content layout. These are the HTML tags. And for CSS, this is what we make the website, or how we make the website pretty. As you can see, there's many, I guess, spaces in between. Many of the things are aligned. These are all achieved by CSS. And Stephanie are playing around the website right now. That's actually what we call JavaScript, in which we create animations or mouth click events. So Stephanie, if you want to click on one of the toggle button, or one of the exercises, you can see we get directed to a new page. And that's achieved by JavaScript. Cool. And with that, I think I'll pass it off to Austin for a quick demo on what we have. Austin,
great. Okay, let me try to share my screen. So I'm going to make a couple just fun changes on the website. And speaking of CSS, we could start out by making a CSS change. So let's just look at this gray part of the site here. So the syllabus scroll page, right now it's gray. Let's try to make it a more fun color by changing the CSS in our code. So I'm just going to look for this text inside of our code base. So if I look everywhere for syllabus scroll, here it is. And we've got some actual text here that describes the way that the syllabus scroll shows up. Like it doesn't have an outline. The font of a heading inside of it are bold. Let's make it red. So if we say background red and then go check it out, it's red. So we can do fun changes like that all over the place. And the main thing that I want to try to do is make a change to this feature where if you click check code and we say auto grader runs as 5, and then we run and check code again, now auto grader runs as 6, we're going to do something a little crazy and try to make that like -700 and see how we would go about doing that. So where to start? So we know, well, I guess a little bit of background, first of all, we have this code that's running inside of your browser. We call this the front end. And then the front end needs to talk to our computer, which we call the back end. And our computer stores data about stuff that you've done. So if I refresh the page, which is kind of like resetting the program that's running on your computer, and click check code again, it still knows how many times you've run the auto grader. So we're keeping that number around somewhere on our computers, and your computer needs to tell our computer what that number is. So let's see if we can find where that message is being passed, and then see if we can change it in some way to make this some kind of crazy number. So I'm going to use the same tool that I used before to look at the CSS. So this is the developer console inside of Chrome, and it lets us see all of the HTML on the page, but also what messages are being passed between the front end and the back end. So if I go to the network tab here, I can see these messages. And if I click run and check code, let's see, this is a good looking message right here. Update num auto grader runs seems pretty relevant to what we're looking for. If we click on that, let me make it a little bit bigger. So we're sending a message to this place in particular. So this is our API, and this is the particular action that we want to perform. And then if we look at the data that we sent, we said that num auto grader run should be 8. And if I scroll this down and then try running again, it sends another message. And this time num auto grader runs should be 9. So maybe if we can find the place in the front end on your computer where it's sending a message to this spot, we can make that do something different. So let's go back to our code and let's search inside of the front end. So I'm going to say find in this front end folder this update num auto grader runs path. Okay, here it is. So we're sending a post request, which just means sending a message to this location that says num auto grader runs should be this new count variable. And that seems to be the most important piece of it. So let's just try setting new count to something crazy like -600. And if we say new count is -600, let's see what happens when we click autograde. So the whole site's gonna reload. This is like clicking stop and run again in your canvas, basically. And let's see what happens now when we click check code. So now autograder runs is 9, and autograder runs is 9 again, and autograder runs is 9. So not quite. It seems like we stopped the number from going up, but it's not going to the place that we want it to go. So let's also look at this network tab again. We are telling the backend, we're telling our computers that num auto grader run should be -600, but it's just refusing to do that for some reason. So we might need to hack a little bit further and go look at the backend and see what the backend is doing with that number. So we can go back to the code here. And now instead of looking in the front end tab, we'll look in the backend tab. So we'll find in the backend num auto grader runs, and this is where it pops up for the first time. So this is a big file that has all of the different endpoints, all the different kinds of messages that you can send to us, and then where the code for handling those messages is. So we will search again for this piece, and here's where it's defined. So this is a lot like an event handler inside of CS Academy. This def post, like how you write def on mouse press, and that is called when you click the mouse. This def post here happens when we get a post request to this particular route. So when you send us a message, this code gets called automatically, and we don't have to write anything to make that happen. We're using a library, just like you're using CMU graphics, that causes this code to be called. So this is actually really similar to what you're learning in a lot of ways. And let's look at the data that we're using here. So the request that you send us has some data, and here's num autograder runs from inside of that data. And then we're getting your exercise submission from the database. That's what this line does. And we're saying if the number of autograder runs that we have stored is nothing, so we've never stored a number before, or the number of autograder runs that you're telling us about is bigger than the number that's already stored, then we're going to make this update. So I think the problem is that we're saying set it to -600, but -600 is not bigger than the number that was already there, 7. So let's just get rid of this if statement and save anything that we get. So we're going to comment that out and just save all the time. And now, if we try to run this and click check code, there we go, -600. And we can go back to the front end and let's try to make it something else just to test it. Where did that URL go? Here's what I'm looking for. Update num autograder runs. Still looking just in the back end. There you go. Okay, so let's make this like, we can make it 10 to the 20 and then click that button again. See how that shows up. Undefined, is it too big? Maybe JavaScript can't handle the number 10 to the 20. I tested 10 to the 10 earlier and that worked okay. There we go. That's a whole lot of zeros. And there, we've done it. We've hacked the site a little bit. But this is actually what the process is like for adding any old feature. So we figure out what it is that we want to change, go see how the front end and the back end interact, and write some code in each of those places to make something interesting happen. Anything else you guys think I should talk about? Feel free to chime in.
I think that looks good.
Cool. Let's move on to the
one really quick question.
Yeah.
Is Python used in CS Academy, and what type of things is Python used for?
Yeah, so the whole backend, or like 90% of the backend, is written in Python. So everything that's running on our computers is Python based. And some scripts that we use just in our day-to-day work too are all written in Python. If I have to do anything that's just like a one-off thing during my day-to-day work, I'm definitely writing that in Python. It's the language that I'm most comfortable with, so we use it all the time in our jobs.
So fun fact, I was the one who implemented the autograder runs feature during my first summer at CS Academy.
We're hacking Tate's code.
Yeah, so thank you so much for that demo, Austin. I guess we can move on to some Q&A questions, just and we prepared a couple. So yeah, I'm just gonna ask a couple questions. So the first is like what specifically does everyone do in CS Academy? So like what have you worked on? What are some of the features that you're most proud of working on? And yeah, just a general overview of kind of what you do would be really helpful for anyone listening in.
Who should start?
Go ahead.
Maybe
Tate, you start.
Yeah.
Me? Okay. I touch a little bit of everything, really. Like I do work on the front end and the back end, and I've done a little bit of work on our infrastructure, we call it, which is like the code that sets up the different computers that we have running and all that kind of stuff. And some of the features that I'm most proud of, I think the work that I've done to make CMU graphics available on the desktop, I think I'm pretty excited about, and also the work that I've done to make our site available in other languages. That's I feel pretty good about having made that happen, especially seeing more people writing code in Spanish and getting Spanish error messages and all that. It's exciting. Tate, you go.
Yeah, I can go next. So I've worked with the dev team for 2 summers, and I would say that I worked mostly on the front end during my first summer, and a lot more on the back end and various other parts during my second summer. And so I've done a little bit of everything, not so much in like terms of like the translation stuff that Austin was talking about, but I've added a lot of like teacher facing UI features and interactions with the back end a little bit. I would say the feature that I'm probably the most proud of, or the 2 that I'm the most proud of, would be, I don't know if this has actually been released yet, but there's supposed to be like a table for teachers where they can compare like the amounts of time that student have spent on a certain exercise. That I don't know if that's been released yet, but
No, I'm hoping to get it out really soon.
Okay. Oops.
But it's so close.
Okay. It'll be
It's okay. You can provide a teaser. Yeah.
Yeah. But yeah, so there's a little teaser, and I and somebody else on the dev team worked on that for most of the summer last summer. And also kind of related to what Austin said, he was the mastermind behind making the Python downloadable version of CMU 112 graphics, but I was able to lay a lot of the groundwork for being able to install it via pip, which if anybody is a little bit more familiar with Python, it's there's modules that you can bring in and do all sorts of cool stuff, like do sound and various other, I'm trying to think of better examples, but there's like other kinds of graphics packages, there's sound stuff, audio analysis, all sorts of things. And those are downloaded via something called pip, which is a package manager. And so I worked a big part of last summer as well on making it so that you can download CMU 112 graphics, not just with the zip file, but also with pip.
You mean CMU graphics, right? CMU 112 graphics.
Oh my gosh, sorry. I'm a 112 TA, and so I get, okay, sorry. Yes, CMU graphics. Whoops.
Who are you popcorning to?
Oh, sorry. Let me popcorn to Sean.
Perfect. Thank you, Tate. I think for me, I worked on the web dev team during the summer semester ago. That's been such a long time now, but I mostly worked on, I think, in the front end, a little bit on the back end. I think for me, the most proud feature that I have done is giving the teacher sign up email once we approve a teacher account. For those who doesn't know, when you request for a teacher account, there's actually a human that would look for it. And then if we find you, we would approve the request and send you a little email as a congrats and get you started. So I've been mostly working on that. And I'll pass it off to Evan.
Great, thanks. Like Austin, since I've been around, I've worked on quite a few different things. But in terms of things I'm most excited about, I think maybe one of the most fun features I worked on was implementing collaborative tasks where multiple people can edit the same file. Partly it was fun because that's sort of just a fun experience, but it was also interesting because I didn't actually have to do that much. There was an open source library that plugged into the open source text editor that we use, and mostly it worked. So it's kind of a miracle of open source where people have created pretty interesting software products and just made it available to use. So we were able to integrate that into the website. It was nice. I also think a lot about how to make sure that CS Academy is always available so that we're not, the website's not down during your class period. And we do pretty well there, but not perfectly anyway. So yeah, I spend a lot of time thinking about that.
Yeah, thank you so much everyone for responding. And it sounds like a lot of people are doing super cool things, and it is really cool to hear what specific features everyone has worked on. Yeah, so this is kind of a a question that's interesting. How did everyone initially start programming, and how did you start getting into maybe not only just programming, but web dev?
I feel like if anybody has watched the previous 2 sessions, or at least one of the sessions, you've probably heard this story before, so I'll try and keep it short-ish, but I actually never programmed until I came to college because my high school didn't offer CS whenever I wanted to take it. And so I took a couple of intro programming classes here at CMU, got really interested in it, even TA'd the first 2 classes that I took. And I ended up just continuing to take classes, and now here I am. In terms of web dev specifically, CMU CS Academy was actually my first programming internship of any sort. During the pandemic, or like the beginning of the pandemic, I applied, I think in like the spring, sometime in the spring, I think it was maybe April, went through the interview process, and that's how I got to the dev team, and how I've done all my web dev experience so far. I'll popcorn to Stephanie.
Oh, yeah. Just
Plot
a
twist.
quick, yeah.
Oh, sorry.
No. Just a quick thing too. Internships are basically this thing that a lot of college students do, where over the summer they spend time at at a workplace, and they really learn how to apply the skills that they learn in college or what they're learning in school in order to see how they're applied in jobs. So it's basically like a short intro to jobs that usually happens over summers, sometimes other semesters. But yeah, and I guess for how I initially started programming, I was really interested. Like, I took my first CS class when I was a junior in high school, so when I was in 10th grade or 11th grade, and I did not like programming. I was like, this is boring. Like, why do I care about these numbers that are like multiplying? I had a really a narrow view of what CS was. But then I kind of I had an amazing CS teacher, and basically he introduced me to this website called Rosalind, and Rosalind, actually one of the co-founders, works at CMU as a professor. But basically it's this open source, it's basically a library of questions that you can do that are computational biology questions. So they apply CS to big bio questions. So when I learned about that, and I started beginning to see how CS could be applied to solve bigger problems, or it could be applied for good in a way, it really sparked my interest. And that's how I really initially got into programming, because I did have that entry in junior year, but then I was like, I don't want to do this. But after seeing how much of an impact it really can have, that's how I continued on and chose to study it in college. But yeah, that's kind of my story, and I'll popcorn it over to Evan because I'm really curious.
Cool. I started programming pretty young. At some point in elementary school, there was a teacher at my school who was just interested in teaching everything. And one thing he taught was, for a few weeks, he taught some basic programming, like the programming language called BASIC, which I think used to be a really common beginner language. And now I'm not sure anyone ever uses it. But anyway, so I started learning programming BASIC, and the way I would do it, I would go to the library, and there were a couple books full of basic programs that were interesting. And so some of them I would go home, and then I'd try to type them in and run them. And sometimes they wouldn't work at all, because I think maybe they were a different version of BASIC. I didn't really understand what I was doing. But some of the books, I started to think, oh, these are the good books, because when I typed them in, something would actually happen. And so, I don't know, I just played around with that for a little bit, and then didn't do a lot of programming for a number of years. And then got back into it in high school. And as far as web development, I think some of my first web development was just doing some projects. I played in the orchestra in college, and the orchestra had a website, and the person who managed the website graduated the year before I came or something. And so I started just with some really basic things on the website, and just gradually got more and more into it. Yeah. How about you, Sean?
Cool. I think for me, quite similar to Tate, I didn't get experience on coding until I came into CMU. Back in high school, there was only one very small computer science course, and out of the 2,000 students we have in high school, it's always packed and I never get the chance to experience it. So I always had that sense of curiosity until I got to CMU, which I took a few intro to computer science course. I got pretty interested, and similar to Tate, I took a course called 15112, which in CMU is a intro to computer science course, as Tate has mentioned before. And as for web dev experience, I think I first got introduced to it in my gap semester. And for those who doesn't know, gap semester, it's like ditching college for a semester, which I always wanted to do when I was a high school student, just ditch school and do something fun. And I was able to get an intern, as Stephanie has already talked about, and learn a bit about how web dev works in general. So cool. I think Austin, you still haven't go, so.
Yeah, I started pretty young as well, like in late elementary or early middle school with this program called Game Maker. I think I've always just been really interested in taking things apart and seeing how they work and building things. And I was like, I'm gonna make a game. And I like read a couple of books and learned how to use this drag and drop system. And then you could also drag a code block in and actually write like text-based code. So I did a little bit of drag and drop programming and then some text-based programming. And then I like taught myself some Visual Basic, not basic, but Visual Basic. So you can make a VB script file on Windows really easily. And I would just like make one that when you click it, it logs you out, which I thought was really cool. And like put the logout script into your login folder so that when you log into your computer, it just automatically logs you out right away. And then I didn't do very much programming in high school, but I kept trying to do like little projects because I wanted to build things. And I think my transition to web development made a lot of sense for me because if I wanted to build things that people were using, like that's what you do, kind of. I guess you can make an app, but the easiest way to get your code out to a large audience is to have it hosted on the internet. So like I tried to make websites and did a really bad job of it in high school, but I like learned some about databases and front ends and back ends and that kind of stuff. And then my first really big project was in college when I had a similar experience to Evan, where I was helping somebody out on this project, and then they graduated and they were like, this is yours now, you got to run this. So I learned how to actually run a project, like a whole online project that way.
Yeah, those are really awesome answers. And it's really cool to hear how like everybody came into programming. And yeah, definitely web dev is a really awesome way to, you know, really get to make full products in that. And so definitely something to consider if you guys are interested in programming and, you know, building things. So yeah, this is another interesting question about like, how does everyone debug tough problems when they're programming?
I can start. I feel like personally, I'm probably stuck the most out of everyone in CS Academy who have ever worked on web dev. So for me, I think if you're interested in computer science, you might have heard of the term print statements. And I think in most computer science language you would ever learn, whenever you encounter a bug, the best way to resolve it is actually just run your program and make sure you see where the bug appears or when does it stop. And by using print statements, you can directly see where the bug appears, and it gives you a better idea on like how to resolve that, which gives you a good start. And along with that, I would say talking with more experienced web dev developers might be the best idea as well, because they have the experience and they always know what's going on. So I'll pass it off to Austin because he is the more experienced web developers.
I was going to say a similar thing. Like sometimes if I get really stuck, I talk to Evan because he has ideas about like places that I might look that I haven't thought to look yet. And also just describing what's going wrong can sometimes just get you to realize what your problem is. So like we call this rubber duck debugging. You just grab anything and start describing what your issue is. And then as you walk through your code, you're like, oh, wait a second. Why am I doing that? that's not what I meant to do. And then you find the bug that way. I think taking a break is always a really good strategy, which is it sometimes feels difficult to do because it feels counterintuitive. You're like, how could it be helpful for me to solve this problem by just not thinking about the problem at all? But you just let your brain reset. And then when you come back and look at your code later, suddenly the problem is just obvious. Yeah, and I do a lot of print debugging, like Sean said, like walk through your code and you know what your variables are supposed to be at every step. And then at some point, your variables are not what they're supposed to be. And the earliest place that something has gone wrong is where your problem lies, usually, for the most part. What about you, Evan? You're the only one who can't go to a more experienced software developer, so.
Well, I do have my ways of doing that though. So I would say sometimes the problem is completely in your own code and you have to do the types of things you were talking about. Sometimes though, you're running into an issue that someone else has found about and written about on the internet. So occasionally, if you run your code and you get some kind of mysterious error message, often if you can, even just select some text and just Google it, then you might get an answer that's helpful. And so I suppose that's one way of like finding people who are even more experienced than me. But these other good ideas. The rubber duck debugging is definitely a real thing for me. I've gotten some, I suppose I've never talked to an actual rubber duck, but I've gotten some good results from explaining problems to people who don't understand what I'm talking about.
Amanda in the YouTube chat says, yes, we give our student ducks, and I found that to be very helpful.
Nice. Tate, do you have any other debugging ideas?
Something I think that I partially got from my my experience in science, because I am a science student, is something that I learned later on actually has like an official name, which is called like scientific debugging. And that's basically like where you're really stuck for a long time on what your bug is. It's especially applicable, I would say, whenever you're doing like larger coding projects. You have no idea like what exactly is going on, but you see an error, you know, like what is happening that, you know, isn't supposed to, and you develop a hypothesis for what might be wrong in your code. So you try and think for a little bit and come up with some possible explanations before you even like touch your code. And then you try and run some tests by changing something inside your code, like printing something or changing the way that you're calculating a variable. And you run the code to see how it changes it. You kind of develop your hypothesis, make predictions that if I print this or I change this, how is that going to change, or how do I think that's going to change the output if that's what's wrong? And then a lot of the times that can kind of pinpoint what the error might be. And if it ends up not being the case, that if it didn't work the way that you expect it to, then you just kind of like repeat the process again. It's literally the scientific method. And I've done that a few times for like the really, really tough bugs, and managed to finally get those working. And definitely, once again, rubber duck debugging. I'm very good at talking to myself, so I don't actually need I don't need a rubber duck or any like item or person to talk to. So I'll just kind of talk out loud to I guess to my computer technically, and I'll explain like why I did each step, and eventually I'll say, wait a minute, that doesn't make any sense, and then I'll change the code. Let's see, Sean, did you go? Oh, okay. Oops. Stephanie, you have not, right?
Yeah.
Okay. Gotcha.
Yeah. Again, I would echo everything said here. Scientific debugging. Me and Tate are actually taking a class to get like currently together. So that's something that we both learned, and it was super, super helpful, not only in that class, but across, you know, programming, even for CS Academy. One last thing I would mention, and I'm not sure, is like clean code is really helpful for debugging too. But also make sure that you're like, it's called Occam's razor, but basically it's like, try to do things in the most simple way and most basic, you know, way that you can do them. Like it's, sometimes it can be super difficult to kind of, keep adding things, but always look at how you can take away things, because sometimes that can really help you, especially when you just have a huge chunk. You're like, I don't know what to do. Maybe look at how you can take away things, how you can make things more simple is something that's been really helpful for me, especially like earlier on when I was starting to learning programming, because I would just have a lot of interesting, this is kind of hard to explain out loud, but instead of saying if this Boolean like type is something, I would say if this Boolean equals true or something like that. And that just adds complexity that you really don't need, right? So just definitely looking at ways that you can just like make your code as simple as possible. It's something that I always look to do, just to make debugging easier too. But yeah, I guess the next question is, this is also kind of related to, just debugging tough problems, but what advice do you have for anyone that's beginning to program? And would you, like, even if you were thinking about talking to yourself like 10 or 5-10 years ago, like what would you say to yourself about learning programming?
I'd say just keep building things. Like just keep trying to make as much new stuff as you can. And I learned a lot of really useful technical skills from classes, but like a lot of practical stuff and stuff that I use in my day-to-day job, I got just from trying to do something. Like I have no idea how to make a website, but I'm going to try. And like looking stuff up and making mistakes, making lots and lots of mistakes and doing things very, very poorly many, many times until eventually I had an idea of what was the right thing to do. I think that was really helpful for me.
Yeah, that makes a lot of sense to me. I think that that matches my experience too. These days, I do really enjoy reading books about programming. And I did some of that when I was getting started, but I feel like it was harder to get as much out of a programming book when I didn't know sort of how things really fit together in a way. So yeah, just trying to do things is great. And if you can find something, I don't know, if you can find a project that's somehow helpful to someone else, I at least find that very satisfying, like making a little website that, I don't know what it would be exactly, it just depends on your situation, but I don't know, like helps your parents keep track of their grocery list or helps your student group like manage some data that they're trying to manage. Yeah, it could be really satisfying to like streamline some tedious process. And also then it sort of forces you to keep working on the project that you started on, which can be good.
Adding on to what Austin Evan mentioned about practice and just continually doing so, I feel like computer science requires that sense of intuition, and that only comes when you practice continuously. It's not like art in which like you have that spark of inspiration. It does require like daily practice in order to be good or proficient at a language. And I would say Stephanie and Tate definitely resonate as well, like especially further on into computer science. When we get to more abstract stuff, it takes a lot of practice in order to get the drill in, to understand the concept. Tate, anything you wish to add?
Yeah, so I would say, I guess, a combination of things. One of them would be to probably start small, just so that it's a little bit more manageable. I think it's good to start with like just getting your hands into some code, and trying to write something, even if it's something a little bit on the smaller side, because developing those skills takes a little bit of time, but also not to get discouraged if what you strive to do someday or strive to do later seems a little bit daunting. I guess to put that in like a little bit more concrete example, I think that, well, I guess this actually, I think the example applies, or the example that I'm thinking of kind of pops more into my head for whenever I started working on like hardware, like I don't want to call it crafting, but like putting together like 3D printed things. And I like to do that as a hobby. or I'm trying to develop that into a hobby. And I found that it was very intimidating at first, the first time I ever tried to do it, which was at like a competition where we had to like build or make additions to like little robots that we were given. But I ended up doing it with my team, and I ended up feeling a lot more confident about it, even though like our robot wasn't as complicated compared to other people's. And some people like attached like pressurized air things so that they like moved with like insane amounts of power and pressure. Ours was not nearly as complicated as that, but it still made me feel a lot more confident about doing these sorts of things in the future. And that definitely applies to programming a lot, because the process is very similar, but it's just all happening inside of your computer. You might start with a small project that, I don't know, maybe you make a calculator in the console, and it prints out little messages, and you give it input, and it gives you the results of little messages that you give it. Even something like that can be a nice starting project to kind of get your hands wet in programming. And the great thing is, as you build more confidence and you start to gain more skills in that respect, while you're doing some research about concepts in maybe the CS Academy notes or your own independent studies online, you start to get a lot more comfortable, and you can take on harder projects. And so over time, you're able to make the small things bigger, or use what you learn from the smaller things to make larger and more impressive things.
Yeah, that's really awesome. And I guess everyone here like has really emphasized, the importance of building, like consistently building, and firstly consistency and continuing to do this, and putting in the work, but also just building these small things that you can really see that are tangible. So that's really cool, just because a lot of the checkpoints and everything really do emphasize on having this like product at the end. So it's really cool that you guys are all getting that experience like right now, and really seeing how you guys can build these small, cool, awesome graphics. But yeah, I guess this can kind of be our last question. Our session's wrapping up a little bit early, but this is a little bit of an open-ended question. Why is CS EdWeek important to everyone here?
I'd say CSEdWeek is important to me because it gives, I think it kind of reflects on how useful it can be to learn a little bit about computer science when you're in high school or before you head off to college, because that wasn't unfortunately that wasn't something that I was able to have, even though I found that programming was a very useful tool eventually, and that it was something that I was passionate about. And I think just being able to get your hands into programming for the first time can not only help you see like whether you're interested in it as a hobby or as a career, but also just so that you get exposed to that kind of different way of thinking that can be applied in other things that you do after school.
I think it's really helpful
okay.
to show people the cool things that programming can do. Like Stephanie said when she was in high school, she was like, why am I just doing all this boring stuff with numbers? But maybe you can see an algorithmic rave. You'll say, okay, wait, maybe this is something that I actually want to learn about.
And adding on to what Austin said, I think this early exposure as you get in CSEdWeek during high school just gives you something that you can keep in the back of your mind when you're applying to college, when you have your free time, and that potentially can be something you check out. And I would say that would be something that's very helpful for everyone later on in the future.
Yeah, I'm excited about the idea of people getting a chance to just sort of try programming a little bit, who maybe wouldn't have actually taken a full course or something like that. I just think it's such a fun, it's such a fun thing to do. It's a fun way to think about problems, to try to get a computer to do your work for you. I hope people will get a taste of that. Yep.
Yeah, I really like, getting the computer to do the work for you. You're just setting everything up, right? And then you're just saying, go, do it. So it is like a new way of thinking in terms of like you're thinking about how to structure things, how to make it so that like it's doing what you're saying. And it's again like more algorithmic thinking. Like you have the algorithm and you're telling the computer to execute what you're doing. So it is it is really cool. And it's definitely a new like a way of thinking that I really only got introduced to like my first or second year of my first and second year of college. So if you guys can like get that, new perspective, it really is helpful, and it'll help you like in a bunch of different ways in like whether it's math or, even bio or just any subject, you can really start thinking about it with this other lens of thinking, which is really helpful. Because you're just like, I feel like a lot of school is just trying to diversify the different ways you can like understand things or you can view things. And that's, whether it's through like, if you're reading something like, and you're looking at the different metaphors of alliteration, like that's more of a literary view, or you're like looking at it through more like, oh, I'm like reading this and this is why the author structured it. Like that's maybe more of, an algorithmic view. But yeah, it is cool how it's just another like basically another glasses lens to put in your toolkit. So yeah, that was a little bit of a ramble, but thank you everyone for tuning in today. It's really awesome that if this is the first session you came to, or this is the last session, we really appreciate you to come and watch these videos. And we really hope that it helps everyone here, get more interested in CS, and happy CS Ed Week.